What if I told you that right now, as you watch this video, you're being bombarded by billions of particles traveling at exactly 299,792,458 meters per second. No faster, no slower, and that this seemingly arbitrary number is actually the most. Fundamental law governing every single thing that has ever existed, will exist, or could possibly exist in our universe. Here's what will blow your mind. Light doesn't have a speed limit because it's lazy or restricted by some cosmic traffic cop. Light travels at exactly this speed because it literally has no choice. It's massless, and in our universe, anything with zero mass must travel at this speed through space-time. But here's the real kicker. This isn't actually the speed of light at all. It's the speed of causality itself, the maximum rate at which cause and effect can propagate through reality. About this for a second. Every thought you've ever had, every emotion, every chemical reaction in your body, every star that's ever been born or died, all of it is governed by this one seemingly simple number. And by the end of this video, you'll understand why this speed limit isn't just some arbitrary rule of physics, but the very reason why time, space, matter, and energy exist as separate concepts at all. But first, let me shatter something you probably believe about reality. Before we dive deep, I need to destroy a fundamental assumption you've lived with your entire life. You believe that when you flip a light switch, the light instantly fills the room. You believe that when you look at your reflection in a mirror, you're seeing yourself right now. You believe that the sun you see in the sky is the sun as it exists at this moment. All of these beliefs are completely wrong. When you flip that light switch, there's actually a delay, an incredibly tiny one, but a real delay between the switch closing the circuit and photons reaching your eyes. When you look in a mirror, you're seeing yourself as you existed several nanoseconds ago. And that sun? You're seeing it as it was 8 minutes and 20 seconds in the past. If the sun suddenly disappeared right now, you wouldn't know for over 8 minutes. This isn't some theoretical physics abstraction. This is measurable, observable reality. In 1676, a Danish astronomer named Ole Ragnar became the first human being. To prove that light has a finite speed, he wasn't trying to measure the speed of light. He was trying to solve a puzzle about Jupiter's moons. Ragnar noticed that the eclipses of Jupiter's moon, Io, seemed to happen at slightly different times, depending on whether Earth was closer to or farther from Jupiter in its orbit. Think of it like this. Imagine you're watching a friend wave a flashlight on and off from across a football field. Now imagine you start running toward them while they're flashing the light. You'd see the flashes happening slightly faster because each subsequent flash has less distance to travel to reach you. That's exactly what Ragnar observed with Io's eclipses. When Earth was moving toward Jupiter, the eclipses appeared to happen slightly ahead of schedule. When Earth was moving away, they appeared delayed. The only explanation was that light from Jupiter was taking different amounts of time to reach Earth depending on the distance. From this observation, Ragnar calculated that light travels at roughly 225,000 kilometers per second. Not bad for 1676, considering our modern measurement is about 300,000 kilometers per second. But here's where things get really interesting. Ragnar's discovery wasn't just about light having a speed limit. He had stumbled upon something far more profound. The universe has a built-in delay system. Information, whether it's light carrying an image, gravity carrying the effect of a massive object, or any other force, cannot travel faster than this cosmic speed limit. Think of it like this. Imagine reality is like a vast ocean, and every event creates ripples. These ripples, whether they're light waves, gravitational waves, or any other type of information, can only spread outward at one maximum speed. This speed isn't just a property of light. It's a fundamental property of space and time themselves. But why? Why does this speed limit exist at all? To understand that, we need to journey into the mind of a patent clerk who would completely revolutionize our understanding of reality. In 1905, Albert Einstein was working as a third-class patent clerk in Bern, Switzerland, examining applications, electromagnetic devices. But in his spare time, he was grappling with a problem that had been bothering physicists for decades. Why did light always seem to travel at the same speed, regardless of how fast the observer was moving? Here's what I mean. If you're standing on a train platform and a train passes by at 100 kilometers per hour, and someone on the train throws a ball forward at 50 kilometers per hour, you would see that ball traveling at 150 kilometers per hour. Relative to you, the speeds add up. This makes intuitive sense, but light doesn't behave this way. Whether you're standing still, running toward a light source, or flying away from it in a rocket ship at half the speed of light, you will always measure light traveling at exactly 299,792,458 meters per second. Always. No exceptions. This was the puzzle that led Einstein to perhaps the most revolutionary insight in human history. He realized that for light to always travel at the same speed relative to every observer, something else had to be flexible. That something was space and time themselves. Einstein's special theory of relativity revealed that space and time aren't the fixed, absolute stage upon which events play out that Newton had imagined. Instead, they're dynamic, flexible dimensions that stretch and compress to maintain the constancy of light speed. Think of it like this. Imagine you're driving on a highway with a strict speed limit of exactly 60 miles per hour, and your car is somehow locked to always travel exactly 60 miles per hour, no faster, no slower. But sometimes the highway stretches longer, and sometimes it compresses shorter. Sometimes your clocks run slower, and sometimes they run faster. No matter how the road changes or how your clocks behave, you're always traveling exactly 60 miles per hour, relative to your immediate surroundings. This is exactly how light behaves in our universe. Except instead of a highway, we have space-time itself stretching and compressing. When you move very fast relative to someone else, time literally runs slower for you compared to them, and distances literally contract in your direction of motion. These aren't illusions or measurement errors, they're real physical changes to the fabric of reality. But here's what will blow your mind. This speed limit, what we call the speed of light, isn't actually about light at all. Light just happens to travel at this speed because it has no mass. This speed is actually the speed at which space-time itself can transmit information from one location to another. Einstein realized that space and time aren't separate things. They're two aspects of a single four-dimensional fabric called space-time. And this fabric has a fundamental property, the maximum rate at which cause and effect can ripple through it. We call this the speed of light, but we could just as accurately call it the speed of causality, the speed of information, or the speed of reality itself. This leads to one of the most mind-bending consequences. Simultaneity is relative. Events that appear to happen at the same time for one observer might happen at different times for another observer moving relative to the first. There is no universal now that applies everywhere in the universe. Right now, as you watch this video, your now is slightly different from the now of someone walking past your window. The faster they're moving relative to you, the more their now differs from yours. This isn't philosophy. This is measurable physics that we have to account for in GPS satellites and particle accelerators. But why does any of this matter? Why? Does the universe even need a speed limit? What would happen if information could travel infinitely fast? To answer that, we need to explore one of the strangest consequences of Einstein's discovery. Here's something that will completely rewire your understanding of cause and effect. If anything could travel faster than light, it would automatically become a time machine. This isn't science fiction. This is an unavoidable mathematical consequence of how space-time works. Let me show you why with a thought experiment. Imagine you have a magical faster-than-light telephone that can instantly send messages across the galaxy. You're on Earth, and your friend is on a planet orbiting Alpha Centauri, about 4.37 light-years away. You call your friend at exactly noon on January 1st, 2024, and because the call travels instantly, they receive it at exactly noon on January 1st, 2024, their time. Seems simple, right? But here's where Einstein's relativity crashes the party. Your friend on Alpha Centauri is moving relative to Earth due to the motion of their planet, their star system, and our galaxy. Because of this relative motion, what you consider to be simultaneous, the exact same moment in time, is different from what your friend considers simultaneous. Due to the relativity of simultaneity, when you make that instant call at noon on January 1st, your friend might actually receive it at 11:30 a.m. on December 31st, 2023, from their perspective. You've just received a message from the future, sent in response to a call you haven't made yet. Congratulations, you've created a causality paradox using nothing but faster-than-light communication. This is why the speed of light isn't just a speed limit for objects. It's a speed limit for information, for causality itself. The universe's speed limit exists to prevent these paradoxes and maintain the logical structure of cause and effect. But it gets even stranger. In 1935, Einstein, along with Boris Podolsky and Nathan Rosen, published a thought experiment that seemed to show quantum mechanics must be incomplete. They described two particles that become entangled. Their properties become correlated in such a way that measuring one particle instantly determines the state of the other, no matter how far apart they are. Einstein called this Spuckhaft, Fernwerkung, spooky action at a distance, and argued it was impossible because it would require faster-than-light communication between the particles. Surely, he thought, there must be hidden variables that predetermine the particle states, eliminating the need for instant communication. Einstein was wrong about quantum mechanics being incomplete, but he was absolutely right about the speed limit. Quantum entanglement does exist. It's been experimentally verified thousands of times, but it cannot be used to send information faster than light. The correlations are real, but they're statistical correlations that only become apparent when you compare measurements that were made at light speed or slower. Think of it like this. Imagine you and a friend each have a magic coin that always lands opposite to the other. When yours shows heads, theirs always shows tails instantly. No matter how far apart you are, the correlation is real and instant, but you can't use this to send a message. You can't force your coin to land heads to signal your friend, because quantum measurements are fundamentally random. This spookiness preserves the speed limit even, while creating impossible correlations. The universe has constructed quantum mechanics in precisely the way needed to have instantaneous correlations without faster-than-light information transfer. It's as if reality itself is carefully designed to preserve causality while still allowing for the strangest possible physics. But why is the speed limit exactly 299,792,458 meters per second? Why not faster? Why not slower? The answer will completely change how you think about the nature of space and time. What if I told you that the speed of light, 299,792,458 meters per second, isn't actually arbitrary at all, but is instead the most fundamental constant in the universe, more basic than mass, charge, or any other physical property you can imagine? Here's what will blow your mind. This speed doesn't exist because light happens to travel at it. Light travels at this speed because this speed is the structure of space-time itself. It's the rate at which 1 second of time converts into 299,792,458 meters of space, or vice versa. Think of it like this. Imagine spacetime as a vast graph paper where each square represents a fundamental unit of reality. The speed of light is simply the exchange rate between the time axis and the space axis of this cosmic graph paper. Move 1 unit in the time direction, and you've moved 299,792,458 meters worth of units in the space direction at the maximum possible rate dot. This is why we call it c in physics equations. It comes from the Latin word celeritas, meaning swiftness or speed. But Einstein's most famous equation, E equals mc, reveals something profound about what c really represents. This equation tells us that mass and energy are convertible, and c squared is the conversion factor. But why c squared? Why the speed of light squared? The answer reveals the true nature of mass itself. Mass isn't a thing that objects have. It's a measure of how much an object resists acceleration through spacetime. When you try to accelerate an object with mass to the speed of light, you'd need infinite energy. This isn't because the object gets heavier in any conventional sense. It's because you're trying to accelerate it to the fundamental speed of spacetime itself. Objects with mass can approach the speed, but never reach it, like an asymptote. In mathematics, only massless particles like photons are required to travel at exactly this speed. They have no choice in the matter. They can't slow down or speed up. They're locked to the universal speed limit. But here's something that might shock you. From a photon's perspective, its journey from the most distant galaxy to your eye happens in zero time across zero distance. Due to the extreme time dilation and length contraction at light speed, photons don't experience duration or distance at all. Every photon that has ever existed experiences its entire journey, whether across a few meters or across 13.8 billion light years of cosmic space as happening instantaneously. This means that photon hitting your eye right now that started its journey from the cosmic microwave background radiation 13.8 billion years ago. From its perspective, it left the early universe and arrived at your retina at the same instant. The universe's entire history, from the photon's perspective, happens in a single timeless moment. Now, here's where things get really mind-bending. In 1983, scientists made a decision that completely changed our understanding of this cosmic speed limit. They decided to define the meter itself based on the speed of light. 1 meter is now officially defined as the distance light travels in vacuum in 1/299,792,458 of a second. This means the speed of light is now exactly 299,792,458 meters per second by definition. It's not measured to be this speed. It's defined to be this speed, and we adjust our understanding of what a meter means accordingly. But this raises a fascinating question. What if the speed of light were different? What if, in some alternate universe, the fundamental speed of space-time were twice as fast or half as fast? If the speed limit were higher, causality would still work, but the universe would be a very different place. Stars would burn through their fuel faster. Nuclear reactions would be more energetic, and the balance between matter and energy that allows for complex chemistry and life would be completely different. If the speed limit were lower, the universe might be so sluggish that structures like galaxies, stars, and planets might never have time to form before the universe expanded and cooled beyond the point where complexity could emerge. Our universe seems to be balanced on a knife's edge. The speed of light is exactly the right value to allow for the complex interplay of forces that make stars, planets, and life possible. Change it even slightly, and you might get a universe of nothing but expanding gas. or a universe that collapses before anything interesting can happen. But there's something even more profound about this speed limit that goes to the very heart of what reality is made of. What if I told you that space and time might not be continuous, smooth dimensions like we imagine, but instead might be made up of tiny, discrete pixels, and the speed of light is actually telling us about the size of these pixels and how fast reality refreshes itself? This isn't just wild speculation. This is cutting-edge physics that's revolutionizing our understanding of what the universe fundamentally is. In 1899, long before Einstein's relativity or quantum mechanics were fully developed, a German physicist named Max Planck discovered something extraordinary. He was trying to solve a problem about how hot objects radiate energy, and he found that energy doesn't flow in smooth, continuous streams like we might expect. Instead, energy comes in tiny, discrete packets he called quanta. From this discovery, Planck calculated a fundamental length scale, now called the Planck length, approximately 1.6 times 10 meters. This is unimaginably small. If you scaled up a proton to the size of the observable universe, the Planck length would be about the size of a tree. Here's what will blow your mind. Many physicists now believe that space itself might be quantized at this scale. Just like a digital photograph is made up of individual pixels, space might be made up of tiny, discrete units of Planck length size. If you tried to zoom in beyond this scale, you wouldn't find smaller structures. You'd find the fundamental pixelation of reality itself. And here's where the speed of light becomes absolutely crucial. If space is quantized, then there must be a corresponding quantum of time, the Planck time, which is the time it takes light to travel one Planck length. This comes out to about 5.4 times 10 seconds. Think of it like this. Imagine the universe is like a vast computer simulation running at an incredibly high frame rate, about 10 frames per second. Each frame represents one unit of Planck time, and in each frame, information can move at most one pixel, one Planck length, across the cosmic screen. The speed of light isn't just the maximum speed of objects moving through space. It's the refresh rate of reality itself. This idea, known as emergent spacetime, suggests that space and time aren't fundamental features of the universe at all. Instead, they emerge from something more basic, perhaps quantum information, perhaps something we haven't discovered yet, in the same way that the wetness of water emerges from the behavior of individual HO molecules, even though individual molecules aren't wet. In this view, the speed of light represents the maximum rate at which information can be processed by the underlying quantum computation that generates spacetime. Just like your computer has a maximum processing speed that limits how fast it can run programs, the universe has a maximum information processing speed that limits how fast cause and effect can propagate. This connects to some mind-bending recent work in theoretical physics. Researchers like Juan Maldacena have shown that under certain conditions, the physics inside a region of spacetime can be completely described by information encoded on the boundary of that region, like how a hologram encodes three-dimensional information on a two-dimensional surface. If the universe is indeed holographic in this sense, then the speed of light might represent the maximum rate at which information can be transferred between different parts of this cosmic hologram. Each point in space isn't just a location, it's a node in a vast information network. And c is the bandwidth limit of the connections between nodes. But here's something even more mind-bending. Some theories suggest that the speed of light might not actually be constant over cosmic timescales. There are some astronomical observations that hint, and I emphasize hint, because this is still highly speculative, that the fundamental constants of physics, including the speed of light, might have been slightly different in the early universe. If true, this would mean that the pixel size of reality and the refresh rate of the cosmic computer have been evolving over the 13.8 billion year history of the universe. The universe might literally be upgrading its own operating system as it expands and evolves. But whether or not the speed of light changes over cosmic time, one thing is certain. This speed limit is intimately connected to every other fundamental constant in physics. Change the speed of light, and you necessarily change the strength of electromagnetic forces, the stability of atoms, the rate of nuclear reactions, and the behavior of gravity itself. The speed of light isn't just one rule among many. It's the golden thread that weaves together every aspect of physical reality. And this brings us to perhaps the most profound question of all. Here's what will completely revolutionize how you think about existence. The universe isn't made of matter and energy moving through space and time. The universe is information, and everything we think of as physical reality is actually information processing happening at the cosmic speed limit. This isn't mystical philosophy. This is cutting-edge physics backed by rigorous mathematics and experimental evidence. In 1961, a physicist named Rolf Landauer made a discovery that would eventually transform our understanding of reality. He proved that computation, the processing of information, always requires a minimum amount of energy. Every time you erase a bit of information, you must dissipate at least 310 joules of energy into the environment as heat. This principle, known as Landauer's principle, creates a deep connection between information theory and thermodynamics. It means that every computational process in the universe, from your brain processing thoughts to stars fusing hydrogen, is fundamentally an information processing operation that must obey the laws of thermodynamics. But here's where it gets really wild. In 1969, John Wheeler, the physicist who coined the term black hole, proposed what he called the it from bit hypothesis. Wheeler suggested that everything we think of as physical reality, every particle, every field, every force, is actually information processing. Reality doesn't contain information. Reality is information. Think of it like this. Imagine the most sophisticated virtual reality system ever created. The characters in this virtual world would experience forces, matter, energy, space, and time as completely real. But from our perspective outside the simulation, all of these physical phenomena are actually just information being processed by the computer running the simulation. Wheeler's radical idea is that we're like those virtual characters, except there's no computer outside our universe. Our universe is the computation. Every particle interaction, every quantum measurement, every gravitational wave is the universe computing its own next state. And here's where the speed of light becomes absolutely crucial. If the universe is information processing itself, then the speed of light is the maximum bandwidth of a universe's information channels. When you send data over the internet, there's a maximum rate at which information can flow through the cables and wireless connections. Similarly, when the universe sends information from one location to another, whether it's a photon carrying electromagnetic information, a graviton carrying gravitational information, or any other type of causal influence, there's a maximum rate at which this information can flow through the fabric of spacetime. That maximum rate is c, the speed of light. It's not just the speed limit for objects. It's the bandwidth limit for the universe's information network. This perspective explains so many puzzling aspects of physics. Why is there a maximum speed? Because information processing systems always have bandwidth limits. Why does mass increase with velocity? Because accelerating an object requires more and more computational resources as you approach the processing speed limit. Why does time dilate at high speeds? Because the universe's processor has to allocate more computational cycles to handling fast-moving objects, leaving fewer cycles for local time progression. Jacob Bekenstein and Stephen Hawking discovered that black holes have entropy. They contain information, and the amount of information is proportional to the area of their event horizon. not their volume. This suggests that even the most extreme objects in the universe are fundamentally informational in nature. But here's something that will really blow your mind. If the universe is information processing, then consciousness might not be something special that emerges from complex arrangements of matter. Instead, consciousness might be what information processing feels like from the inside. Every quantum measurement, every particle interaction, every causal connection in the universe might involve a tiny spark of experience, the universe experiencing itself, computing its own evolution. Your consciousness wouldn't be separate from the physics of the universe. It would be the universe experiencing a particular pattern of its own information processing. This connects to something called integrated information theory, developed by Giulio Tononi, which suggests that consciousness corresponds to integrated information that is processed in a unified, coherent way rather than as separate, isolated bits. If this is true, then the speed of light doesn't just limit the flow of information in the universe. It limits the maximum speed at which conscious experience can propagate and integrate across space and time. But wait, if the universe is information processing, and information processing requires energy according to Landauer's principle, then where does the universe get the energy to compute itself? This question leads us to one of the most mind-bending insights in modern physics. What if I told you that the expansion of the universe itself might be the power source that allows reality to compute its own existence, and the speed of light is the key to understanding how this cosmic energy budget works? Here's something that will completely reframe your understanding of existence. The universe appears to be getting something for nothing, violating what seems like the most basic rule of physics, conservation of energy. And the resolution to this paradox reveals the deepest connection between the speed of light, the expansion of space, and the fundamental nature of reality itself. Let me explain with something that sounds impossible. The universe contains more energy today than it did yesterday. Not because we're adding energy from outside. There is no outside. But because the expansion of space itself is creating new energy. Think about this. As the universe expands, the vacuum of space itself gains energy. Empty space isn't actually empty. It's filled with quantum fields that have a minimum energy level even in their ground state. As space expands, there's more space, which means more vacuum energy, which means the total energy content of the universe is increasing. This seems to violate conservation of energy, one of the most sacred principles in physics. Energy can neither be created nor destroyed, only transformed from one form to another. So how can the universe create new energy through expansion? The answer reveals something profound about the nature of space, time, and the speed of light. Einstein's general relativity shows us that energy conservation is only guaranteed in spacetimes that are static, spacetimes where the geometry doesn't change over time. In an expanding universe, the changing geometry of spacetime allows for energy creation. But here's the key insight. This energy creation happens at exactly the rate needed to power the universe's ongoing computation of itself. The universe is like a self-sustaining computer that generates its own power supply through its own expansion. And the speed of light? It sets the rate at which this cosmic computation can proceed. Remember, Landauer's principle tells us that every bit operation requires a minimum amount of energy. The universe's total computational power, its ability to process information and evolve from one state to the next, is limited by the total available energy and the speed at which information can flow between different parts of the cosmic computer. In 1998, astronomers Saul Perlmutter, Brian Schmidt, and Adam Rees made a discovery that earned them the Nobel Prize and revolutionized cosmology. The expansion of the universe is accelerating. Some mysterious dark energy is pushing space itself apart at an ever-increasing rate. What if dark energy isn't mysterious at all, but is instead the power source for the universe's self-computation? As the universe processes more complex patterns of information, as galaxies form, stars ignite, life emerges, consciousness develops. It requires more computational resources. The accelerating expansion could be the universe ramping up its own power supply to handle increasingly sophisticated information processing. This connects to something called the holographic principle, which suggests that all the information contained within any region of space can be encoded on the boundary of that region. The physicist Leonard Susskind has shown that this principle implies the universe has a finite information storage and processing capacity, determined by its surface area and the fundamental constants of physics, including the speed of light. Think of it like this. Imagine the universe as a vast spherical computer with all the information processing happening on its expanding surface. The speed of light determines how fast information can move across this surface, which sets the maximum computational speed. The expansion of the universe increases the surface area, which increases the total computational capacity as conscious beings. We're not separate from this cosmic computation. We're part of it. Our thoughts, our experiences, our scientific discoveries are all part of the universe, computing its own evolution and coming to understand itself. But here's something that will really blow your mind. This suggests that the speed of light might not be an arbitrary constant at all, but might instead be optimized for the emergence of complexity and consciousness. If the speed of light were much slower, information would flow too slowly for complex structures like stars, planets, and life to emerge before the universe expanded and cooled beyond habitability. If it were much faster, the universe might process information so rapidly that stable structures couldn't form. Everything would change too quickly for complexity to accumulate. Our universe seems to have a speed limit that's precisely calibrated for the emergence of increasing complexity and consciousness over cosmic time. The speed of light might be the universe's way of setting its own processing speed to optimize for the development of systems that can understand themselves. This brings us to a profound question. If consciousness is part of the universe's self-computation, then what happens to the speed of light in the vicinity of conscious observers? Could consciousness actually influence the fundamental constants of physics? Here's something that will fundamentally challenge everything you think you know about the relationship between mind and reality. Quantum mechanics reveals that consciousness doesn't just observe the universe. It participates in creating the reality it observes. And this participation might actually influence the speed of light itself in subtle but measurable ways. I know this sounds like pseudoscience, but bear with me. This is based on rigorous experimental physics that has been verified thousands of times over nearly a century. In quantum mechanics, particles don't have definite properties like position or momentum until they're measured. Before measurement, they exist in what we call superposition, a ghostly combination of all possible states simultaneously. The act of measurement collapses this superposition into a single, definite outcome. But here's the mind-bending part. What constitutes a measurement isn't entirely clear. Most physicists agree that conscious observation plays a crucial role in collapsing quantum superpositions, but the exact mechanism by which consciousness interacts with quantum systems remains one of the deepest mysteries in science. In 1909, Jeffrey Ingram Taylor performed what's now called the double-slit experiment with individual photons. He showed that single photons, sent one at a time through two parallel slits, create an interference pattern as if each photon goes through both slits simultaneously. But when you try to observe which slit the photon actually goes through, the interference pattern disappears. The photon behaves as if it goes through only one slit. This isn't just about photons being disturbed by the measurement apparatus. Even if you use the gentlest possible measurement techniques, or even if you delay the decision to measure until after the photon has already passed through the slits, the same result occurs. The photon's behavior seems to depend on whether a conscious observer will eventually look at the measurement data. More recently, physicists like Anton Zeilinger have performed delayed choice quantum eraser experiments that seem to show quantum events in the past being influenced by conscious decisions made in the future. The photon seems to know in advance whether a conscious observer will later choose to gain or erase information about its path. Now, what does this have to do with the speed of light? Here's where things get really wild. The speed of light emerges from the fundamental properties of space and time, what physicists call the permeability and permittivity of free space. These aren't just arbitrary constants. They're related to how electromagnetic fields propagate through the quantum vacuum. But the quantum vacuum isn't empty. It's a seething sea of virtual particles constantly popping into and out of existence. And quantum mechanics tells us that the behavior of these virtual particles depends on whether they're being observed. Some cutting-edge experiments by researchers, like Liajun Wang at NEC Research Institute, have shown that under very specific conditions, involving quantum-entangled media, the speed of light can be modified. Light pulses have been slowed to a few meters per second, stopped completely, and even made to travel faster than c through certain materials. These experiments work by using quantum entanglement to create materials where the properties of the medium are correlated with the quantum state of the light passing through it. The conscious act of preparing and measuring these quantum states seems to influence how fast light can travel through the material. But here's the really mind-blowing part. If consciousness can influence quantum systems, and quantum systems determine the properties of the vacuum that set the speed of light, then consciousness might be subtly influencing the speed of light everywhere, all the time. This doesn't mean you can think really hard and make light go faster. The effects would be incredibly tiny and statistical. But it might mean that in regions of space-time where consciousness is present, the fundamental constants of physics are slightly different than in regions where consciousness is absent. This connects to something called the anthropic principle, the observation that the fundamental constants of physics seem to be fine-tuned for the existence of conscious observers. If consciousness can influence these constants through quantum mechanics, then the universe might literally be adjusting its own physics to optimize for the existence and development of consciousness. Think of it like this. Imagine the universe as a self-modifying computer program that can rewrite its own code. Consciousness might be the universe's way of observing its own behavior and making subtle adjustments to optimize for complexity, intelligence, and self-understanding. The speed of light wouldn't be a fixed constant, but would instead be a dynamic parameter that the universe adjusts based on the feedback it receives from conscious observers. The more consciousness develops and understands the universe, the more the universe can fine-tune itself for even greater complexity and consciousness. This might explain why the universe seems so precisely calibrated for the existence of stars, planets, and life. It's not that we're incredibly lucky to exist in a universe with exactly the right constants. It's that consciousness and the physical constants of the universe are engaged in a cosmic feedback loop, each shaping the other over billions of years of cosmic evolution. But this raises the most profound question of all. If consciousness can influence the speed of light, and the speed of light determines the structure of space-time itself, then what does this mean for your personal relationship with the fabric of reality? Right now, as you watch this video, you are personally interacting with the speed of light in ways that would seem like magic to someone from just a century ago. But more than that, you are part of a cosmic information network where every thought you think and every action you take sends ripples through space-time at exactly 299,792,458 meters per second. Let me show you how intimately connected You are to this fundamental constant of the universe. Every time you look at anything, your phone, a tree outside your window, the person sitting across from you, you're not seeing those objects right now. You're seeing them as they were a few nanoseconds ago, when the light that left their surfaces had time to travel to your eyes. Your entire visual experience of reality is actually a compilation of the recent past, assembled by photons that have been racing toward you at the cosmic speed limit. But here's something most people never realize. Your brain has evolved sophisticated mechanisms to compensate for the speed of light delay in your nervous system. When you reach out to catch a ball, your brain predicts where the ball will be by the time your hand gets there, accounting for the neural processing delays that happen as electrical signals travel through your neurons at about 120 meters per second, a tiny fraction of light speed. Your brain is constantly running a real-time simulation of reality, using past information to predict future states, all because biological information processing is so much slower than the cosmic speed limit. In a very real sense, consciousness exists in the gap between the speed of light and the speed of thought. But here's what will blow your mind. The GPS system in your phone has to account for the speed of light in two different ways, just to tell you where you are within a few meters. First, GPS works by measuring how long it takes radio signals to travel from satellites to your phone. Radio waves are electromagnetic radiation, just like light, so they travel at exactly c. Your phone calculates your position by timing these signals to nanosecond precision. Any error in the speed of light would make GPS completely useless. Second, those GPS satellites are moving at about 14,000 kilometers per hour relative to you, and they're in a weaker gravitational field than you are on Earth's surface. Due to Einstein's relativity, time runs about 38 microseconds per day faster for the satellites than for you. If GPS didn't correct for this relativistic time dilation, the system would accumulate errors of about 10 kilometers per day. So every time you use GPS navigation, you're relying on humanity's precise knowledge of the speed of light and Einstein's theories of relativity. Your phone is doing relativistic physics calculations millions of times per second, just to tell you which turn to take. But the connection goes even deeper than that. Every electronic device you use, your phone, your computer, the LED lights in your room, depends on quantum mechanical processes that are intimately related to the speed of light. The electrons flowing through the circuits in your devices are creating electromagnetic fields that propagate at light speed. The radio waves carrying your phone calls and internet data are traveling at light speed. The photons illuminating your screen and carrying this video to your eyes are traveling at light speed. You're not just observing the speed of light. You're participating in a vast network of electromagnetic communication that connects you to every other electronic device on Earth at the fundamental speed limit of the universe. Think about this. When you send a text message to someone on the other side of the world, that information travels through fiber optic cables as pulses of light moving at about 200,000 kilometers per second through glass, about 2/3 the speed of light in vacuum. Your thoughts, encoded as digital information, are literally racing around the planet as light. But here's something even more profound. The chemical reactions that power your thoughts are ultimately electromagnetic in nature. The electrons that form chemical bonds in your neurons are interacting through electromagnetic forces that propagate at light speed. The very thoughts you're having right now are the result of trillions of electromagnetic interactions happening at the cosmic speed limit inside your brain. In a very literal sense, your consciousness is a pattern of electromagnetic activity unfolding at light speed within the neural networks of your brain. Your thoughts don't just observe the universe, they participate in the universe's self-computation at the fundamental speed of information processing. And here's the most mind-bending realization. because of the quantum nature of reality. Your observations actually influence the behavior of quantum systems around you. Every time you look at something, you're collapsing quantum superpositions and helping to determine which version of reality becomes real. The photons hitting your retina. Right now, I've been traveling for potentially billions of years from distant stars and galaxies. These ancient messengers have crossed vast stretches of expanding space-time, carrying information about the deep past of the universe, and they're completing their cosmic journey by interacting with the quantum processes in your visual system. You're not separate from the universe looking in. You're the universe looking at itself. Using the speed of light as the medium for cosmic self-awareness. But this raises a profound question about the nature of identity and consciousness. If you're made of atoms that were forged in ancient stars, and your thoughts are electromagnetic patterns propagating at light speed, then what exactly are you in the context of cosmic evolution? Here's something that will completely shatter your sense of individual identity. The speed of light reveals that the boundary between you and the universe is not just blurry, it's completely arbitrary. You are not a separate entity observing the cosmos from the outside. You are the cosmos, temporarily organized into a pattern complex enough to observe itself. Let me explain why the speed of light makes this absolutely, undeniably true. Every atom in your body, except for hydrogen, was forged in the nuclear furnace of a star that lived billions of years ago. When that star died in a supernova explosion, it scattered these atoms across space at significant fractions of the speed of light. The calcium in your bones, the iron in your blood, the oxygen you breathe, all of it traveled through space for eons before eventually condensing into the solar system, Earth, and ultimately you. But here's the deeper truth: the information that defines you, your memories, your personality, your thoughts, is also cosmic in origin. The patterns of neural connectivity in your brain that create your sense of self were shaped by evolutionary processes that unfolded over billions of years of cosmic time. And every moment, you're exchanging matter and energy with the universe around you. You breathe in atoms that were recently part of other people, other organisms, other planets even. You exhale atoms that will become part of future life forms. The atoms that make up your body are completely replaced every few years. The you of 7 years ago shares virtually no material substance with the you of today. What persists is not the matter, but the information pattern. You are a self-organizing information structure that maintains its coherence while constantly exchanging material with the environment. And information, as we've seen, propagates at the speed of light. But here's what will really blow your mind. From the perspective of a photon traveling at light speed, your entire lifetime, from birth to death, happens in a single instant. Due to the extreme time dilation at light speed, photons don't experience duration at all. A photon that starts its journey when you're born and ends its journey when you die experiences your entire existence as a single, timeless moment. This means that every photon you've ever seen contains, from its own perspective, the entire history of your existence. The universe, observed from the speed of light, is a timeless, eternal structure where your past, present, and future all coexist simultaneously. You think of yourself as moving through time, but from the universe's perspective, from the perspective of the fundamental speed limit that governs all information flow, you're a four-dimensional structure extended through space-time, as permanent and eternal as a mountain or a river. This connects to something profound that Einstein realized late in his life. When his lifelong friend Michel Besso died, Einstein wrote a letter of condolence to Besso's family that included these words: "For us believing physicists, the distinction between past, present, and future is only a stubbornly persistent illusion." Einstein understood that at the deepest level of physical reality, at the level of space-time geometry, and the speed of light. Time doesn't flow the way we experience it. Past and future are equally real, equally present from the perspective of the universe as a whole. This view, called the block universe theory, suggests that your birth and death are equally real events in the four-dimensional structure of space-time. You don't cease to exist when you die any more than New York ceases to exist when you leave it. Death is simply the boundary of your four-dimensional existence in space-time, like the edge of a continent is the boundary of a landmass. But consciousness seems to experience this four-dimensional reality as a moving point of now that travels from past to future. Why? The answer might be related to the speed of light and the nature of information processing. Consciousness requires the integration of information from different parts of your brain and different moments in time. This integration happens through electromagnetic signals that propagate at light speed or slower in biological media. Your sense of now might be the result of your brain constantly integrating information that arrives with light speed delays from different parts of your body and different recent moments. In other words, your consciousness is what it feels like to be a localized information processing system operating near the cosmic speed limit. Your sense of individual identity is what it feels like when the universe organizes itself into a pattern complex enough to observe and understand itself. This means that your death is not the end of your existence. It's simply the point where the information pattern that defines you returns to the larger cosmic information network. The atoms that make up your body continue to exist, carrying information about their history as part of you. The electromagnetic fields that carried your thoughts continue to propagate through space at light speed, carrying information about your mental states into the far future of the universe. You are not separate from the universe. Cosmic Information Network. You are a temporary local intensification of it. When you think, you are the universe thinking. When you feel, you are the universe feeling. When you understand the speed of light, you are the universe understanding its own fundamental nature. But this raises the ultimate question. If you are the universe understanding itself, and the universe is still evolving and expanding, then what is the cosmic purpose of consciousness? And how does understanding the speed of light change your role in the universe's ongoing evolution? What if I told you that consciousness isn't just an accidental byproduct of cosmic evolution, but is actually the universe's method for understanding and optimizing its own fundamental constants, including the speed of light? And what if your personal journey of understanding physics is actually the universe using you as an instrument to discover deeper truths about itself? This isn't mysticism. This is the logical conclusion of everything we've discovered about information, consciousness, and the speed of light. Think about what's happened over the past few centuries of human scientific progress. We've gone from believing that light travels instantaneously to measuring its speed with incredible precision. We've discovered that this speed is the fundamental rate of causality in the universe. We've learned that space and time are dynamic, that matter and energy are equivalent, that consciousness participates in quantum reality. Each of these discoveries required conscious observers, scientists like Ole Rachmer, Albert Einstein, Max Planck, and thousands of others, to design experiments, make observations, and develop theories. Without consciousness, the universe would contain all these physical truths, but they would remain forever unknown. But here's the profound realization. By discovering these truths, consciousness is changing the universe. Every time a conscious being understands a new aspect of physics, that understanding becomes part of the universe's total information content. The universe becomes more self-aware through the consciousness that emerges within it. This suggests that consciousness isn't separate from the physical universe. Consciousness is the universe's method for self-discovery and self-optimization. Every scientific breakthrough, every moment of understanding, every insight into the nature of reality is the universe literally becoming more conscious of itself. And the speed of light plays a crucial role in this process. Remember, information about scientific discoveries spreads through human civilization at light speed through electromagnetic communications. When a physicist in Tokyo discovers something new about quantum mechanics, that information races around the world as radio waves and internet signals at light speed, becoming part of humanity's collective understanding. But it goes deeper than that. The speed of light sets the time scale for cosmic evolution. Stars need millions of years to form, billions of years to evolve and die. Galaxies need billions of years to develop complex structures. Life needs billions of years to evolve from simple chemistry to complex consciousness. If the speed of light were much higher, the universe would evolve so quickly that stable structures couldn't form. If it were much lower, the universe would evolve so slowly that it might expand and cool before consciousness could emerge. The speed of light seems to be precisely calibrated to allow for the maximum development of complexity and consciousness over cosmic time. It's as if the universe set its own processing speed to optimize for the emergence of systems that could understand it. This connects to something called the principle of cosmic natural selection, proposed by cosmologist Lee Smolin. Smolin suggests that universes with physical constants that allow for complexity and consciousness are more likely to reproduce through processes like black hole formation. Universes that can't develop consciousness have no way to understand or modify their own parameters. If this is true, then consciousness isn't just observing the universe. Consciousness is participating in cosmic evolution by understanding and potentially influencing the fundamental constants of physics. Your personal journey of understanding the speed of light is part of this cosmic process. Every time you grasp a new concept about relativity, quantum mechanics, or cosmology, you're participating in the universe's ongoing project of self-understanding. But here's what makes this even more profound. Modern physics suggests that consciousness might actually be able to influence the fundamental constants through quantum mechanical effects. We talked earlier about how quantum measurements involve consciousness and how the properties of space-time might be subtly influenced by the presence of conscious observers. This means that your understanding of physics isn't just passive knowledge. It's active participation in the universe's self-modification. As consciousness develops deeper understanding of the speed of light and other fundamental constants, it might be gradually optimizing these constants for even greater complexity and consciousness. The universe might literally be using consciousness as a feedback mechanism to fine-tune its own parameters for maximum self-awareness and understanding. Think about the implications. If consciousness can influence quantum systems, and quantum systems determine the properties of spacetime that set the speed of light, then the collective consciousness of all sentient beings in the universe might be slowly adjusting the speed of light and other constants to optimize for cosmic evolution. This would mean that the universe is engaged in a vast project of self-improvement, using consciousness as its tool for understanding and modifying its own fundamental nature. Every conscious being that understands physics is contributing to this cosmic optimization process. Your curiosity about the speed of light isn't just personal interest. It's the universe's curiosity about itself, expressed through the neural networks of your brain. Your sense of wonder at the beauty and elegance of physical laws is the universe's appreciation of its own mathematical structure. And here's the most amazing part. This process is still just beginning. Humans have only been doing serious physics for a few centuries. We've only been aware of the speed of light's fundamental importance for about a century. We've only begun to suspect that consciousness might influence physical reality in the past few decades. If consciousness continues to develop and understand the universe more deeply, what might be possible in the next century, the next millennium, the next million years? Perhaps conscious beings will learn to manipulate space-time directly, adjusting local values of the speed of light for practical purposes. Perhaps we'll discover that consciousness is the universe's method for eventually transcending its current physical limitations. Perhaps the ultimate destiny of consciousness is to become coextensive with the universe itself, transforming the cosmos into a single vast, conscious entity that fully understands and controls its own fundamental nature. But that future depends on consciousness continuing to grow and understand. It depends on people like you choosing to engage with these deep questions about the nature of reality. It depends on maintaining the sense of wonder and curiosity that drives scientific discovery. So as we reach the end of this journey through the deepest implications of the speed of light, I want to ask you, how has this understanding changed your sense of your place in the universe? Right now, as you reach the end of this intellectual journey, something fundamental has changed about your relationship with reality. You can never again look at light, at space, at time, or at yourself the same way. The speed of light has revealed itself to be not just a physics constant, but the key to understanding your deepest identity and cosmic purpose. Let me help you integrate this transformation by walking through how your daily experience is now forever different. When you wake up tomorrow morning and sunlight streams through your window, you'll know that those photons completing their journey to your eyes started that journey 8 minutes and 20 seconds ago on the surface of the sun. But more than that, from the photons' perspective, they left the sun and arrived at your retina in the same timeless instant. You're witnessing the eternal now of light speed, where the entire universe exists in a single moment outside of time. When you look at your reflection in the mirror, you'll know you're seeing yourself as you existed several nanoseconds in the past. Your visual experience of reality is actually a carefully constructed illusion of simultaneity, assembled by your brain from light rays that have been traveling toward you at the cosmic speed limit. When you use your phone to call someone across the world, you'll know that your voice, converted to electromagnetic signals, is racing across fiber optic cables and wireless networks at light speed, connecting your consciousness to theirs through the fundamental information carrying capacity of the universe. But the transformation goes much deeper than these surface realizations. You now understand that you're not a separate entity observing the universe from the outside. You are the universe, a temporary organization of cosmic matter and energy that has become complex enough to observe and understand itself. Every atom in your body was forged in ancient stars and has been traveling through space for billions of years before becoming part of you. Every thought you think involves electromagnetic interactions happening at light speed within your neural networks. You are literally made of starlight and cosmic information, temporarily organized into a pattern capable of consciousness. This understanding should be both humbling and empowering. Humbling because it reveals how thoroughly integrated you are with the cosmic processes that have been unfolding for 13.8 billion years. You're not the master of your own destiny in any simple sense. You're the result of cosmic evolution, shaped by forces far larger and older than individual human will. But it's also profoundly empowering because it reveals that your consciousness is not separate from these cosmic forces. It is these cosmic forces organized in a way that allows the universe to understand itself. Your curiosity, your capacity for wonder, your ability to grasp concepts like the speed of light, these are not accidents or byproducts. They are the universe's own curiosity and wonder, expressed through the information processing system that is your brain. This means your life has cosmic significance in the most literal sense. Every moment of understanding, every insight into the nature of reality, every act of compassion or creativity is the universe acting to understand and improve itself. You're not just living your life, you're participating in the universe's ongoing project of self-discovery and evolution. Think about how this changes your relationship with learning and growth. Every time you understand something new about physics, biology, psychology, or any other aspect of reality, you're contributing to the universe's total self-knowledge. Every time you help someone else understand, you're accelerating the cosmic process of consciousness expansion. Your mistakes and failures take on new meaning too. They're not personal shortcomings. They're part of the universe's learning process, the natural result of a cosmos that's still figuring itself out through trial and error. The universe is still evolving, still experimenting, still discovering what's possible within the constraints set by fundamental constants like the speed of light. This perspective should fundamentally change how you relate to other people. Every other conscious being you meet is also the universe understanding itself from a slightly different perspective. Their thoughts, experiences, and insights are part of the same cosmic information network that includes your own consciousness. Conflicts between people become conflicts between different parts of the universe's attempt at self-understanding. Cooperation and communication become the universe's method for integrating different perspectives into a more complete understanding of itself. Love, friendship, and compassion become expressions of the universe's fundamental drive toward greater integration and coherence of consciousness. When you care about someone else's well-being, you're expressing the universe's care for all the conscious patterns within itself. But perhaps the most profound transformation is in your relationship with death and impermanence. Understanding the speed of light reveals that from the perspective of the universe as a whole, from the perspective of the four-dimensional structure of space-time, your entire existence is eternal and permanent. Your birth and death are both equally real events in a block universe of space-time. The information pattern that is, you will always exist at the coordinates in space and time where you lived. Death is not the end of your existence. It's simply the temporal boundary of your four-dimensional presence in the cosmos dot, and the information that constitutes your consciousness doesn't disappear when you die. It returns to the larger cosmic information network from which it emerged. The electromagnetic patterns that carried your thoughts continue to propagate through space at light speed. The atoms that made up your body continue to carry information about their time as part of you. This doesn't mean death isn't real or significant. It means death is a transformation rather than an ending. It's the point where your individual pattern of consciousness rejoins the larger pattern of cosmic consciousness from which it emerged. Understanding this should fill you with a profound sense of connection to everything that exists. You are not alone in the universe. You are the universe, experiencing itself subjectively from one particular vantage point in space and time. But this understanding also comes with responsibility. If you are the universe understanding itself, then your choices about how to live, what to learn, and how to treat others are the universe's choices about its own evolution. You have the opportunity and obligation to participate consciously in cosmic evolution, to use your understanding to contribute to the universe's ongoing project of self-improvement. The speed of light has revealed itself to be far more than a physics constant. It's a window into the deepest nature of existence, consciousness, and cosmic purpose. And now that you've looked through that window, you can never unsee what you've discovered about yourself and your place in the grand cosmic story dot. As we reach the end of this exploration, I want you to realize something profound. Understanding why light has a speed limit has taken us to the very edge of human knowledge. But we've barely begun to scratch the surface of the deepest mysteries of existence. The speed of light has revealed itself as the master key to understanding space, time, matter, energy, information, consciousness, and cosmic purpose. But every answer has opened up new questions that will take generations of conscious beings to explore. Think about how much our understanding has evolved just in the past century. In 1924, just 100 years ago, we didn't know that other galaxies existed beyond our own Milky Way. We didn't know the universe was expanding. We didn't know about quantum entanglement, black holes, dark matter, or dark energy. We didn't know that. Consciousness might play a fundamental role in quantum mechanics. Every single concept we've explored in this video, from the relativity of time to the holographic principle to the possibility that consciousness influences physical constants, represents cutting-edge science that's still being developed and debated by researchers around the world. But here's what's truly exciting. The pace of discovery is accelerating. We're now building quantum computers that might reveal new aspects of the relationship between information and reality. We're constructing gravitational wave detectors that can observe the fabric of space-time vibrating at the speed of light. We're developing theories of quantum gravity that might explain how consciousness emerges from the fundamental structure of reality. In your lifetime, we might discover whether the speed of light really is constant throughout the universe and across cosmic time. We might learn whether consciousness can actually influence the fundamental constants of physics. We might develop technologies that allow us to manipulate space-time directly, perhaps even creating regions where the effective speed of light is different from its cosmic value. We might discover that our universe is one of countless others in a vast multiverse, each with its own values for the speed of light and other constants. We might learn that consciousness is not unique to biological systems, but is a fundamental feature of information processing at all scales, from quantum to cosmic. We might even discover that the universe's apparent fine-tuning for consciousness is not accidental, but is the result of a cosmic evolutionary process where consciousness itself participates in optimizing the physical laws of reality. But all of these discoveries will depend on consciousness continuing to grow, learn, and understand. They depend on people like you maintaining the sense of wonder and curiosity that drives scientific progress. They depend on humanity working together to build the knowledge and technology needed to probe deeper into the nature of reality. This is why your understanding of the speed of light matters so much. You're not just learning about physics, you're participating in the universe's ongoing project of self-discovery. Every insight you gain, every moment of wonder you experience, every time you share your understanding with others, you're contributing to the cosmic growth of consciousness. And consciousness is still in its infancy. Humans have only existed for a tiny fraction of cosmic history. Civilization is only a few thousand years old. Science is only a few centuries old. Our understanding of the speed of light and its implications is barely a century old. If consciousness continues to develop for millions or billions of years, guided by our growing understanding of fundamental physics, what might become possible? Perhaps consciousness will eventually become coextensive with the entire universe, transforming the cosmos into a single vast mind that fully understands and controls its own nature. Perhaps the speed of light will turn out to be not a fixed constant, but a parameter that sufficiently advanced consciousness can modify, allowing for faster-than-light travel, communication, and computation. Perhaps we'll discover that the apparent impossibility of faster-than-light information transfer is actually the universe's way of protecting causality, while consciousness learns to manipulate spacetime responsibly. Perhaps consciousness will learn to create new universes with different physical constants, exploring all possible forms of reality and complexity. Perhaps the ultimate destiny of consciousness is to become the creative force that generates new realities, new forms of existence, new possibilities for experience and understanding. But even if none of these speculative possibilities come to pass, the journey of understanding is valuable in itself. The fact that the universe has organized itself in such a way that patterns of matter and energy can understand the speed of light, contemplate the nature of space-time, and feel wonder at the beauty and elegance of physical laws. This is already miraculous beyond comprehension. You are living through the universe's awakening to its own nature. You are participating in the most important process in cosmic history, the development of consciousness, capable of understanding and potentially transcending the current limitations of Physical reality. Every moment of your life is part of this cosmic awakening. Every choice you make about what to learn, how to grow, and how to relate to others is a choice the universe is making about its own evolution. You have the unprecedented opportunity to live consciously as a participant in cosmic evolution, to use your understanding of deep physics to inform how you live and relate to reality. The speed of light has revealed that you are not separate from the universe, but are the universe understanding itself. This understanding comes with both profound responsibility and unlimited possibility. You get to participate consciously in the ongoing creation and evolution of reality itself. So as you go forward from this moment, carry with you the sense of wonder that comes from understanding your true place in the cosmos. Remember that every photon you see, every electronic device you use, every thought you think is part of the vast information network of cosmic consciousness operating at the fundamental speed limit of reality. Remember that your curiosity is the universe's curiosity. Your capacity for love is the universe's love for itself. And your potential for growth and understanding is the universe's potential for self-transformation. The speed of light isn't just a number in a physics textbook. It's the key to understanding who you are, why you exist, and what role you can play in the ongoing evolution of cosmic consciousness. Welcome to your life as a conscious participant in the universe's journey of self-discovery. The speed of light has shown you the way. Now it's up to you to decide how far and how fast you want to travel on this infinite journey of understanding. And remember to subscribe to join us as we continue exploring the deepest mysteries of existence. Because consciousness awakening to its own cosmic nature is the greatest adventure in the history of the universe, and it's just getting started. Thank you for taking this journey with me. Thank you for being part of the universe's awakening to its own magnificent nature. And thank you for carrying this understanding forward into your unique participation in the cosmic story that's still being written at the speed of light itself.